This is Darren Marchant for American Nomad News, and somebody on Facebook asked an interesting pair of questions. It's really, I think, meant to kind of say one question, but it's compound sex. It's asked as two questions, and that is, what happens if an asteroid hits the moon and destroys it, and will it affect the Earth's tides? This is a pretty interesting question. So I wrote up a big answer to that, and I got some likes and a wow on it. So I thought I would share it with you tonight, and I'm going to read what I wrote and post that on Facebook and probably on YouTube. That is an excellent pair of questions. There are a lot of variables relevant to that question. The first is, what is the mass of the asteroid? The second would be, what is its speed? The third would be, what is the trajectory of the asteroid? The relative mass is important to define the potential to disintegrate the moon. You see, there is something of a logical fallacy in your question, because the mass of the moon would not be destroyed. The moon would break apart if it were hit with enough force. The more mass, the more it would break apart. The speed relative to the moon would be a factor in the force calculation. The trajectory is important because it would define where on the moon it would hit and at what angle. If the impact were a glancing blow, much of the force would be deflected, and like a game of billiards, the asteroid would impart a factor of delta V or change of velocity, to the overall rotation and direction of the mass of the moon. The pattern of composition of the moon would be very important in the final determination, as it would define the nature of the distribution, mass, and size of particles disturbed. How much of the mass of the moon would remain in orbit around the Earth, and for how long, as well as what portion would fall to Earth, what portion would leave the orbit of Earth, and how long would it take for the mass with a stable orbit around the Earth to form a new moon, if any. I would be inclined to investigate what effect this event might have on the stability of the orbit of the Earth around the Sun, the stability of the Earth's rotation on its axis, the change in magnetic field lines, tidal patterns, total thermal budget change from lunar plus asteroidal mass, global thermal budget change. I'm going to advance this so I can read the rest, because it's actually partially off of the screen. It won't let me highlight. Okay, there we go. So just highlight that one little word so I can keep track of where I'm at. And then, okay, try and do this. Okay. Figure out where I'm at here. Total global thermal budget change from lunar asteroidal mass heating up on entry into the atmosphere, global cooling resulting from the combination of lunar and asteroidal material blocking sunlight from space, ash from falling mass burning up in the atmosphere, ash from volcanic activity, ash from the global fires that would result from falling mass, as well as the fires caused by tsunamis, heat added to the global thermal budget from ignited methane hydrate deposits, greenhouse gas emissions from volcanic activity, damaged industrial containment, forest fires, non-ignited methane hydrate, and vaporization of frozen components of lunar asteroidal mass as it enters the atmosphere, not to mention the transfer of heat from the mantle to the atmosphere from the escaping lava. The ISS would be screwed, and any space-based colonies would be at risk, depending on an ever-expanding set of variables that you might not have patience with me on. I hope that goes some small way to answering just how screwed we would be. Darren Marchant. Well, I hope you enjoyed that little short bit. I am currently working on learning how to use the YouTube publishing. I don't have any ability to edit these videos, so they're pretty much coming at you raw, and if my presentation is a little rough and stilted, please forgive me. I'm working on learning how to do this. Thank you very much.